Hey everyone, welcome to our lesson on data distributions. A distribution is basically just a visual way to represent some amount of data that you have gathered. You can use lots of different types of these visual displays. You may see your data distributed in the form of a line plot, which would look something like this. You're going to have your X and Y axis labeled with some appropriate increments, and you'll sort of mark each data value within those increments wherever they should go as you're gathering your data. Or you may see it displayed in the form of a box plot. Sometimes people refer to these as box and whisker plots, which just basically shows you the area where most of your data falls. You will put things like the max and the min labeled on these, the median, and other terms like the quartiles, the Q1 and Q3. So you can just see where most of your data falls. It's a good visual display of that. Or you may choose to use a histogram and see data displayed that way, where, similar to a bar graph, you can see how high your data has reached according to the increments over here on the y-axis in the form of these bars. Okay, some things that you'll want to be on the lookout for after you've graphed or displayed your data is what kind of shape it makes. That's going to tell you a lot about what's happening with your data. Sometimes you'll end up with data that has had a uniform shape or a level shape where everything ends up being the same value. So if your histogram started looking like this, that is a uniform shape because it's constant all the way across, same level. You may distribute your data and notice that it forms some type of symmetrical shape. It's got some type of symmetry. Maybe it's increasing to a point and then decreasing, or maybe doing the opposite, maybe decreasing and then increasing. Or you may notice that after you graph your data in a display, it is sort of uneven on one side, sort of skewed to one side or the other. So that's what that term skewed means. Terms that you'll need to know as you're working with data and statistics are these here. These are going to be the measures of center. Okay, things that tell us about the center or the middle of our data are going to be average, mean. You're going to take all your values, add them up, and divide by the number of numbers that you're working with. Median, it's going to be the middle value. So you're going to put them in an ordered list from least to greatest and look for that middle value. Mode, you will hear about mode, which is the number that is occurring the most. And with mode, there may not be a number that occurs the most, so you'll say no mode. There may also be a tie between two numbers or three, so you can list both of those as the mode if that happens. Alright, so in this data set here, if you were to calculate that out in your calculator, you can practice and use these numbers and try that. You should come up with a mean of around 9.3 for this list of numbers here. The middle number is going to be our value of 10. You can see that one right in the middle. And then the mode, the most occurring, let's look through. I can see that the 12 occurs twice, so he will be the most occurring mode. These are our measures of center. Okay, other terms that you'll come across that deal more with the spread of your data, you know, how far spread out your data values are. It's called standard deviation. That just has to do with how far your data values are spread away from your mean. Okay, if you have a large standard deviation, that's going to mean that your data is more spread. And range tells us about our spread because range comes from the highest value minus the lowest value. So that tells us our whole range of data values and the values that they're spanning across. So we're going to practice and we're going to make one of these visual displays of data. So you can take a look here at the bottom. We've got a list of scores for some class that took a pretest. And we want to display that visually to see what kind of shape we come up with. So let's work on that. Let's use a line plot to do this. So when you're making these displays, it's about you deciding the appropriate increments, for your data. You may want to go up each unit by 1. You may want to use intervals on your bottom line labelings. It usually doesn't matter. You have to decide what's appropriate, for your display. For this one, we can look through and see that we have scores anywhere from scores in the 60s to the 90s on this pretest. So we could go do intervals of 10, maybe 60 to 70, 70 to 80, and so forth. And then we'll plot each one and see what it is that we're working with, what kind of shape. So if I were making this one, I may go down to the bottom and do my intervals as 60 to 69 values. In that range will go there. And then 70 to 79 and so forth. 80 to 89. 90 to 99. I won't end up needing this last line because it doesn't look like we have any scores over that. Alright, so you can just go through and plot each data value, and then we'll cross them off as we do. So the first one's 64. We're going to be in that interval. 66, I'm going to put here. Also, 75 is going to fall over into the next one. And then we've got a 78. Okay, used him. 79 is still in that range. Then we're moving to 80, so we're going to go over to the next range. And it may help. Our data happens to be in order, but if yours is not, you can go ahead and order at least to greatest, and it'll help you as you're doing these. 83 is in this interval as well. We have 2 of those. 87 and an 89. This one's really high. Okay, and then 92 is going to fall in the next range, and our last one, 95. Okay. So instead of me looking at a list of numbers now that may or may not tell me a lot, now I can see a nice shape of these scores, and it has more meaning. I can see that most people scored in the 80 to 89 range fairly well. Didn't have too many people, on the low end, had a couple on the high end. So it's got some symmetry to it, fairly normally distributed. And I have more meaning for my data this way when I display it visually. So this concludes our lesson on data distributions.